Hello, my name is Lieutenant Chandra Roberts. I work for the Clayton County Fire and Emergency Services in Clayton County, Georgia. So this video presentation today is just a brief synopsis of fire behavior and fire dynamics. This is going to serve as like an introduction to the course that we are going to be going through this semester. So I just wanted to touch on a few things to kind of further explain fire dynamics. So in order to be a successful and safe and efficient firefighter, you need to know the basics of fire, how fire works, how fire behaves, and those things. So those are a few things that we're going to touch on today. We're going to touch on the 5 classes of fire. We're going to talk about the difference in flames, pre-mixed and diffusion. We're going to talk about the heat of combustion and combustion efficiency. I'm also going to touch briefly on the dangers of smoke and how flame applies to smoke. So just a little introduction to fire dynamics, and we'll jump right in. So first of all, I want to talk to you about the classes of fire. There are 5 classes of fire. I found a method that helps me to remember each class of fire according to the letter that's associated with that class. So the first one is Class A. Class A fires are going to be your ordinary combustibles. So this is paper, wood. I like to think of it as A for ash. Anything that will burn and make an ash is your ordinary combustible, and those are Class A fires. They can be extinguished with Class ABC fire extinguishers, which are your basic fire extinguishers that you see pretty much everywhere. Class B is your combustible liquids. I use the word bucket, B for bucket. Anything that will fit into a bucket is your combustible liquids, and that's Class B. Those can also be extinguished with an ABC extinguisher. Moving on to Class C. For C, I use the word computers. C is for energized electrical equipment. That's your computers, anything that's plugged in, appliances, those things are Class C, and they could also be extinguished with an ABC extinguisher. Class D are going to be your combustible metals. That's your titanium, magnesium, aluminum. Those things cannot be, I wouldn't suggest that they be extinguished with an ABC extinguisher. For those, you want to use a dry powder chemical, which is more effective for extinguishing those fires than using water. And the last class is Class K. I use K for kitchen. These are going to be your cooking oils, your animal fats. These are typically found in your restaurants and buildings with large kitchens, universities, and things of that such. And you'll notice that they have a different extinguisher than regular occupancies. They're usually a big silver extinguisher, and those are your Class K. So A for ash, B for bucket, C for computer, D for dry powder, K for kitchen. And those are your 5 classes of fire. Okay, so what is fire? So we're going to talk about the fire triangle. The fire triangle is a fundamental training point for the fire service, and it was used up until the 1960s. So the fire triangle has 3 parts, and that's heat, fuel, and oxygen. And originally it was believed that as long as you had these 3 components together, that you would have a fire. And once you remove one of those components, the fire would be extinguished. Well, in the 1960s, another component was added to these 3, that triangle, and it became known as the fire tetrahedron. This added a chemical reaction. So you still have the heat, the fuel, and the oxygen, and now you've added a chemical chain reaction. And what that states is that a continuous chemical chain reaction must occur between the fuel and the oxygen in the presence of heat for there to be fire. And the same applies with the tetrahedron as well as the triangle. If you remove one of those products, the fuel, the heat, the oxygen, or stop that chemical reaction, then you extinguish the fire. All right, so moving on to the heat of combustion. So the heat of combustion is how much energy a fuel can release when it's oxidized. In fires, complete combustion is never attained, meaning that the efficiency of combustion is never at 100%. And that's because of a lot of things. It's because of the loss of heat into the atmosphere as the fire is burning. It's putting off heat and it's taking away from the actual fire. And also because of the diffusion of oxygen that's coming in when you have fires that are burning in open spaces and spaces with a lot of oxygen. So when we're talking about the heat of combustion, we have to include flames. A flame is a visible luminous body where oxidation reaction is occurring. That's your combustion zone. The flame is a part of the fire that we see. Another component of that is smoke. In relation to flame, smoke is the byproduct of that combustion. So it's all the fire gases that are coming off of the flame, and that's the smoke that we see. So flame and smoke work hand in hand. Now, we're going to talk about two different types of flames. One of those is a diffusion flame. A diffusion flame is where oxygen is introduced to the fuel at the combustion site. So typically through the air. The resulting combustion occurs where the fuel and air mix within the fuel's flammable range. And that's when you have that high orange flame. Another type of flame is your premixed flame. And that's where the fuel gases and the oxygen are already mixed before they reach the combustion zone. Those flames are typically short and blue. So if you think about maybe a Bunsen burner, when you have a diffusion flame, that flame it's really tall and it's bright yellow or orange, maybe even red. That's because the fuel and the oxygen meet at one point in the combustion zone. And then if you have another example with the Bunsen burner, if the air inlet is closed, you've got your premix, so where the fuel and the oxygen are already mixing together. So when it's lit, then your flame is a short blue flame, kind of like what we see on gas grills and gas stoves and things like that. Okay, so moving on with flame, we said that, not flame, with smoke. Smoke is the byproducts of the flame, the combustion flames. The dangers of smoke is that people feel like, the smoke it's not hot, or it can't burn you. And when actuality it can. And what makes smoke more dangerous, I feel, is all the byproducts that are inside that smoke. What smoke is the unburned pyrolysis products that may act as fuel if heat is introduced. So just because there's smoke and no flame doesn't mean that smoke isn't dangerous, because at any time, if there's heat or if there's fuel introduced, the heat is introduced to that fuel and that smoke, a flame can start immediately. So that's one of the dangers of smoke. So these are just a few things that are the basics of fire, and in no form or fashion did I go over everything, but this is just some of the main things that you need to keep in mind when studying fire dynamics and learning fire behavior. And like I said, in order to be a successful and effective and safe firefighter, you have to understand how fire works. You have to understand fire behavior to know where it's going and what's gonna happen before it happens, so that you and your crew can make it home safely at the end of the day. Thank you.